Welcome to the massive open online course on Aspen Plus. This course will enable one to learn the use of Aspen Plus software for process calculation, process engineering calculation, modeling, and simulation. Before going into the details of this course, let us go through a short preamble which will enable us to understand what is process modeling and simulation in general and how Aspen Plus can be used for this purpose. Let us consider this process plant. Now, this is not actually a full-fledged plant, rather it's a small unit of a large plant. Now I will explain the individual equipment that are present over here. The main equipments in this unit are one distillation column, there is another distillation column over here, there is a pump, there is a small reactor, and there are also an heater, and there is a mixer. So the process feed is passed through this heater and the mixer in series before it is fed into the reactor. The reactor output is then fed into the distillation column. Here the distillate is the product of this unit P1 and the bottom stream of the distillation column 1 is fed into the second distillation column where the distillate is product number 2 of this unit. The bottom stream of the distillation column is then pumped back to the mixer. It is a recycle stream. So basically the mixer mixes the fresh feed and the recycle stream, and the mixture is then fed into the heater to get heated up, and it is sent to the reactor. Now, in addition to this main equipment, there are plenty of other ancillary equipments and devices such as measuring devices, control system units, there are various pipelines, there are safety devices and alarms, and there are mechanical structure as well which are necessary to build these process units. Now for the time being, these are not important for the focus of our discussion. We pick and choose only these 6 units for our discussion because these are the principal units. Now, we make a schematic of the process plant where we have kept the principal units, that is mixer, the heater, the reactor, distillation unit 1, distillation unit 2, and the pump. These 6 units we have kept. All other things we are not interested about. Now, what happens in this unit of the process plant? We give feed. Feed means the material feed. The feed which is being heated up before it goes to the reactor and the reaction happens. The reactor content is then distilled. That is the feed, material feed. And also we have energy feed. Because we have to operate heater, we have to operate the condensers and the reboilers of the distillation column. We have to operate the pump. We need electrical energy. So basically, in this process plant, we have to give two types of feed. One is material feed, another is energy feed. And the product we will get out of it, this is P1 and this is P2. Two types of products. So ideally, we have to make sure that these products, they are up to the desired standard of their quality and quantity. In other words, we have to make sure that the product rate, the flow rate of the product and its quality is maintained. Now, whatever we have in the process plant, what could be the major tasks of a process engineer out of it? What may be the duties? The first one, we may have to design a new plant. This plant may not be in an existing condition. As a process engineer, we may have to design it for some purpose, and that design can be given to the fabricator for fabrication and then installation. In order to do that, we have to do certain calculations based on some mathematical calculations, or we may have to work with an existing plant of this nature which is there for years together. It might have served us for several years before the market demand has changed the scenario. In the market, nowadays the product quality may be different in demand. So we have to change the product quality. Earlier, say 95% purity might be enough, but nowadays our competitor is selling at the same price a 99% purity. Obviously, then our product will not be sold in the market. In such situation, we have to revamp our process to meet the market demand. So, we have to change a few things. We do not know what to change, but we have to do some what-if analysis. That means, if we change the heater temperature, if we change the condenser pressure, if we change the reboiler ratio, how far the product quality will change. So these are the various what-if analysis that we can do in order to arrive at the market demand quality. Now, these things cannot be done in the real life plant. The plant manager will not allow one to go and meddle with the system. So, one needs to do on pen and paper some calculation. How to do that calculation? We all know we have to replace these processes, or we have to replace this equipment with their mathematical counterpart. Here you see we have replaced the mixer, heater, CSTR, all of them have been replaced by a set of differential and algebraic equations. And these equations have been taken from textbook. They are well-known equations. They have been developed from mass balance, energy balance, rate equations for CSTR, the vapor-liquid equilibrium in case of distillation column, etc. So these are all standard equations whose structures are same. No matter which distillation column you use, they remain same. What changes? The number of trays change in a distillation column. The components change. In one distillation column you may work with methanol, another distillation column you can work with ethanol, and so on. So based on the component that you use, your property database will change. The flow rate, temperature, pressure, those things will change, but the structure of equation remain same. So if your structures are same, you need to feed the data. When you work with mathematical formulation, the real life feed is not of any use. Here you have to use the data. If it is flow rate, then you have to give some information about how many kilomoles per hour or how many kgs per hour, or what is the quality, whether 50 mole percent or 25 weight percent, etc. And also energy data in terms of joule, or for a continuous system it is wattage, joules per second. So these data have to be fed into the process and the calculations can be done. All these equations